Good morning to you all. Uh, Today we are going to see about the traveling salesman problem in the branch and mount technique. So the cost matrix will be given to you in the problem, or if they give in the form of a graph wise, what are all the edges are there to the corresponding vertex, you need to write to form the cost matrix. Or if the cost matrix is given directly, then there is no problem. So this is a cost matrix we need to they have given in the problem. With this we are proceeding this. The very first step is we need to find the fully reduced matrix. So the fully reduced matrix can be found out by using two ways. One is of row minimization, and then the next way is of column minimization. These two steps you need to do as mandatory. So first I am going to do for the row minimization. In row minimization, in each row we need to find the minimum value. So in this the minimum value is 10, and then the second row the minimum value is 2, and then the third row the minimum value is 2, and then the fourth row the minimum value is 3, and then in the fifth row the minimum value is 4. So after this you add all those things. So if I add all the minimum values in the row wise, I will be getting as 21. So this is the cost of this is the total cost we will be getting it. So the next step what we need to do uh, after finding the minimum value in each row is this value should be subtracted with the each row, and then this 2 should be subtracted with the second row, and then the minimum value should be subtracted with the third row. So likewise if you follow, infinity minus of 10 will be as infinity, and then 20 minus of 10 will be as 10, 30 minus of 10 will be 20, 10 minus of 10 will be 0, 11 minus of 10 will be 1. So similarly the procedure should be followed by subtracting 2 with the second row, and then this value with the third row, and this value with the fourth row, and then this value with the fifth row. So after subtracting we will be getting the matrix to be like this. And then in this one rule should be followed. If a row or a column contains any one zero, we need to ignore that particular row or column. So this is a mandatory rule we should follow. If any row contains any one zero, or a column contains any one zero in the column, that particular row or column should be ignored. Similarly, if a row or column contains every values as infinity in a row or a column wise, then that should be ignored. So these two rules you should keep it in your mind when you're performing row minimization and column minimization. So in this what we should do here is we are in the row minimization. After subtracting with all the minimum values in the row wise, the table we will be getting. So in that again I am going for row minimization. In the first row 0 is there, we should ignore this. Second row 0 is there, we should ignore this. Third row 0 is there, ignore it. And then fourth row again 0 is there, ignore it. Fifth row again 0 is there, ignore it. So in this the row minimization will be as 0. So and then we can proceed with the column minimization now. So after if there is no possibility of getting row minimization, we can go for column minimization. In the column minimization, in each column we need to find the minimum value. In this minimum value is 1. In this column contains 0, so we need to ignore this column. So I am putting as cross mark. So in this column 3 is minimum, and then in this 0 is there, so I am ignoring this column. In this 0 is there, I am ignoring this column. So again for the next step, this value should be subtracted with this column, and then this value should be subtracted with this column. So when I do this, so 1 that is infinity minus of 1 is infinity, 13 minus of 1 will be as 12. So the same thing should be followed. Similarly for the third column, 20 minus of 3 will be as 17. The same thing should be separated with 3 with all the third column values. Rest of the things the same should be appeared in the a matrix. So again you check for the column minimization after subtracting that value. So again in the column 0 is there, ignore it. Again the column 0 is there, ignore it. Again this column 0 is there, ignore it. Again this column 0 is there, ignore it. So at last the column minimization also will be 0. So this is said to be the fully reduced matrix. The fully reduced matrix is obtained that when the row minimization and column minimization will be a 0, that is we can't proceed it further. So what you should do is, now we need to find the cost of fully reduced matrix, that is the cost of row minimization plus cost of column minimization. So in the first step we have found for the row minimization, that is the total is of 21. So that should be proceeded with the row minimization of 21. And then the column minimization add this value 1 plus 3, that is 4. That is 4, so that should be given here. Even when you are proceeding with the next step, if you are getting the column minimization value, that value can be added with the previous column minimization value, but here we are getting 0, so 0 plus 4 will be as 4. Again here the row minimization will be 0, so 0 plus the previous step of 21 will be as 21, so the row minimization value will be 21, column minimization will be 4, the total will be as 25. So now we need to proceed that totally it is a 5 cross 5 matrix, so 5 nodes up, so 5 nodes will be there. So starting from always it will be starting from the source, so 1 2 3 4 5, so node 1 node 2 node 3 node 5. So here from each node we need to find the possible distance. So what we need to do is so here starting from first node to second node, first node to third node, first node to fourth node, first node to fifth node, we need to find it out. So how we need to find this, we can represent the name node 1, node 2, node 3, node 4. So node 1 the path is of 1 2, so the first row, so path is of 1 2, so how we should assign in the sense means the first row we need to assign as infinity, and then the second column as infinity, and then in the fully reduced matrix 2 comma 1 should be assigned as infinity. So let us take this fully reduced matrix. In this fully reduced matrix only we are going to do this. So first row to be as infinity, so the first row is everything to be in infinity, and second column, so second column is fully as infinity, and then next 2 comma 1 cell, so this is 2 comma 1 cell, that is assigned as infinity. So the remaining thing will be of the same values of in the fully reduced matrix, that should be replaced here. So again we need to do the row minimization and column minimization. The row minimization, everything is infinity, here 0 is there in you should ignore it, here 0 is there, ignore it, here 0 is there, ignore it, here 0 is there, ignore it. So row minimization is 0, column minimization, here 0 is there, ignore, so fully infinity ignore, so here 0 ignore, here 1 0 ignore it, here two zeros are there, ignore it. So column minimization also 0, so row minimization and column minimization cost will be 0. So the cost will be as the cost of node 1 of the path 1 comma 2 will be given as cost of fully reduced matrix plus cost of row minimization plus cost of column minimization plus the matrix element of 1 comma 2, that is path of 1 comma 2, so that is the matrix element of 1 comma 2. So this matrix element of 1 comma 2 represents that actual fully reduced matrix 1 comma 2, that is the fully reduced matrix 1 comma 2 is so this 1 comma 2 is 10 so that value should be replaced. So here the matrix element of 1 comma 2 will be as 10, and then row minimization column minimization value for this path we have calculated as 0 and 0, that should be substituted. And then cost of fully reduced matrix is, so the original value, that is in the fully reduced matrix the first step what we have calculated, that is the cost, so that is a 25, that should be applied here, so adding you will be getting as 35, so that should be done here. So the cost is of 1 comma 2 will be as 35. So similarly we need to do for all of those things, so 1 comma 3 1 comma 4 1 comma 5. So when we do that we will be getting this as the 35, and then 53 25 and then 31. So in this the path the minimum cost you should choose, and so the minimum cost is of 25, so we need to proceed with this. So the path is of 1 and 4 is done, so the next remaining vertices are 2 3 and 5. So we need to proceed with this. See here the minimum is of 25, I'm proceeding with this path. The next remaining unvisited vertices are 2 3 and 5, I'm going with the 2 3 and 5. So now the path will be as 1 4 2 we need to find. So 1 4 2, so first row should be infinity, fourth row should be infinity, fourth column should be as infinity, again second column should be infinity, and then what we need to assign in the fully reduced matrix is 4 comma 1 should be assigned as infinity, again 2 comma 1 should be assigned as infinity. So now all this should be done in your matrices. So everything I am doing it, first row as infinity, fourth row as infinity, fourth column second column as infinity, assign 4 comma 1 as infinity, 2 comma 1 as infinity, 4 comma 1 as infinity, 4 comma 1 as infinity, 2 comma 1 as infinity, and rest of the thing what I have did, what I am going to what I have said to assign, that should be assigned in the fully reduced matrix. So in the fully reduced matrix it is assigned. So now you check for row minimization column minimization, fully infinity, so ignore it, 0 ignore it, 0 ignore it, fully infinity, ignore it. 1 0, ignore it. So row minimization will be 0. Column minimization 1 0, ignore it. Fully infinity. Again here 0, fully infinity. Again here 1 0, ignore it. So the column minimization cost is of 0. So 0 and 0. So at last the cost of fully reduced matrix plus cost of row minimization plus cost of column minimization plus here 142, that is the path we are finding for 142. So 142 is the matrix you should take is as 4 comma 2. So the actually the in the fully reduced matrix the 4 comma 2 value is this is fourth row. 4 comma 2 is 3. So the 4 comma 2 is 3. I am taking this 3, and then the row minimization, column minimization is 0 0, and then cost of fully reduced matrix at the first step what you have find the fully reduced matrix 25. So that should be done here. Here the value is 28. So this should be updated here in the 28. So similarly we need to find for 143 and then 145 by doing this the same procedure. Okay, so after doing this you will be getting as 28, 50 and then 36. So in this we need to find the minimum. So minimum is of 28. So go with this procedure. So 142 is visited, so remaining is of 3 and 5. So remaining is of 3 and 5. So 3 and 5 I am proceeding it. So the path 1423 you should calculate it. 1423 how we need to calculate is first row is infinity, fourth row infinity, second row infinity, again fourth column infinity, second column infinity, third column infinity, again 4 comma 1 should be assigned as infinity, 3 comma 1 as infinity. So if you do all these things in the fully reduced matrix, so you will be getting like this. Again find for row minimization. So here row minimization we have got the value as 2 and then 11. So this should be subtracted. So at last after subtracting you will be getting, again checking for row minimization. I am checking for column minimization, so 0. So row minimization total value will be as 13 and then column minimization will be as 0. So after that we can find the path 1423 as cost of fully reduced matrix plus row minimization plus column minimization plus matrix of 2 comma 3. So matrix of 1423 in the sense means we need to take the matrix of 2 comma 3. So the matrix of 2 comma 3 the value in the fully reduced matrix we will be getting as 2 comma 3. 2 comma 3 is 11. So 2 comma 3 the value will be getting as 11 you will be getting. So I am substituting his. So the row matrix, the cost of row minimization is 13, column minimization is 0, cost of fully reduced matrix 25. So total will be as 49. So this should be updated in this path. So similarly for node 10 we need to calculate by following the same procedure by assigning this. So at last 25 will be getting. So we can conclude this as finally we can conclude this as everything the value will be getting here as here 3 and then here 5 will be getting here 49 and then for 5 it is of 5 you have got it as 25. So this is as the path 1425 1425. So 1425 this is the actual path you will be getting. Okay, so this is a traveling salesman problem. Okay, practice it. If you have any doubt you can ask to me. Thank you.